Okay, today we're going to go over the alternating series error bound, which is a way to approximate the error and therefore kind of the value of an alternating series. However, this error bound test only works for alternating series. All other infinite series, you'll have to use the Lagrange error bound, which I'll go over at a later date. You'll notice that I'm trying to get more into infinite series, and I'll continue onward. I'm just trying to make this review as quick as possible. So let's get into it. So the equation for the error at the point n is equal to the absolute value of the true sum of the series minus the sum at the nth term. And that happens to be less than or equal to the nth plus 1 term. This means that at any given point, the difference between the true sum of the series and the sum of the series at an nth term is equal to the next term in the sequence. Okay, so this is practice problem 1. I'm told to approximate the sum of the infinite series from n equals 1 to infinity of negative 1 to the power of n over n squared using the first 4 terms. So let's call our approximation, or let's call the sum of the series s, and the approximation is going to be s sub 4. And it's just going to be equal to the first 4 terms, as you probably could have guessed. Those being negative 1, because we just use 1 in place of n, plus 1 over 4, minus 1 over 9, plus 1 over 16. And I've already calculated this. This right here is equal to negative 799. Okay, before I introduce this second part of the problem from practice problem 1, I'm going to make a few minor adjustments. This right here should be n equals 1. This should be negative 0.75. Okay, so we're asked whether or not n equals 1 to infinity of negative 1 to the power of n over n squared could equal 0.75. Now, as I said earlier, the summation of an infinite series at point n plus or minus the nth term plus 1 is going to be greater than or equal to the true sum of the series. So we can lay this out with some sort of primitive interval. We can call this part s sub n, which is going to be s sub 4 because we're referencing the last problem, which happens to be negative 0.99. And this part here can be the upper bound of the interval. We're going to add our a plus nth plus 1 term, sorry, a sub n plus 1 term, which by the way is negative 1 over 25. And this happens to be negative 7.59. And the lower bound is negative 0.838 because we're adding it here, we're subtracting it here. So this is our interval of whatever the summation of our infinite series could possibly be. And you'll notice that negative 0.75 does not fit within this interval, and therefore, whatever the sum is, it is not, and it could not be equal to negative 0.75. Okay, so this is practice problem 2. We're told to find the amount of terms needed for the infinite series of n equals 1 to infinity of negative 1 to the power of n plus 1 over n factorial to have an error of within 1,000. And let's rewrite 1,000, or sorry, 0.001. Let's rewrite that to 1 over 1,000. It'll just be easier. And let's equate this infinite series to s. So s is equal to the first term, which is 1 over 1 factorial, minus the second, which is 1 over 2 factorial. In fact, let me simplify these. 1 over 1 factorial is 1 over 1. 1 over 2 factorial is 1 over 2. Plus 1 over 3 factorial, which is 1 over 6, minus 1 over 4 factorial, which is 1 over 24, plus 1 over 5 factorial, which is 1 over 120, minus 1 over 6 factorial, which is 720. And you'll notice as we approach this next one that we're nearing 1 over 1,000. It has to be within 1 over 1,000. So the next term, which is 1 over 7 factorial, is actually 1 over 5,040. Now, 5,040 is even less than 1 over 1,000. And so this term is the one that, not this term, the one before is the one that allows the error to be within 0.001, because this is actually less than that. So these first 6 terms allow for a 6 plus 1 to be less than or equal to 0.001, meaning it's not the 7th term that caused this, or there aren't 7 terms needed to have an error within 1/1000. In fact, it's actually 6, and that is our final answer.